Alright, welcome back. In this lesson we're going to look at rational expressions. Kind of the key to this lesson is just simplifying. That's all we're doing is simplifying. We're not solving for any variables or anything like that, just simplifying things down a little bit. Later on in the chapter we'll be solving for some variables. So simplifying rational expressions. We've done things like this before. 3x squared y over, say, 6xy squared. And we could simplify that down to 3 over 6 is 1/2, right? So 1/2. 2x is on top, 1 on bottom, leaves 1 on top, 1y on top, 2 on bottom, leaves 1y on bottom, right? We've done that, so we could say this is equal to x over 2y. If we have something like 1/4 plus 2/5, we can't go simplifying the value 2 over 4 here because we have this plus in between. We need multiplication in between our factors in order to simplify things in the numerator and the denominator. So if we just have this plus here and no multiplication, then we can't go crossing things off. So if we look at this problem, this is what we're going to be dealing with. So I can't go crossing off x squared over x squared and 8 over negative 2x over x because we have these pluses and minuses in between them. But what we can do is we can do a little factoring. So you guys remember how to factor. We can factor this top here to, let's see, do it in my head here, x plus 4 times x plus 4. And on bottom, let's see, we could factor this guy out to 6 and 4, so that should be x minus 6 and x plus 4. Alright, so we have two factors that are the same on top and bottom. We have x plus 4 on top, and we have x plus 4 on bottom, so we can go ahead and cancel those out. So this will equal x plus 4 over x minus 6. And I know you really want to say that this is equal to, okay, x over x cancels out, and 4 over 6 is 2 over 3, so maybe it's negative 2 over 3. This is not the answer. Since we have our plus here and our minus in between our factors, we cannot go canceling them out. Only if we have multiplication. Here is multiplication, and here is multiplication between our two factors. Then we can cancel things out. Since we have this plus here and this minus, this is as far as I can go. This is my answer. Alright, let's look at another one. This is fun. So we have something a little bit more complicated here. So we have this factor, x squared minus 4, over x squared minus 1 times x plus 1 over x squared plus 2x. So I don't see anything the same on top and bottom. So I can't cancel out anything yet. But what I can do is, probably guess it by now, is do some factoring. So let's take a look at this x squared minus 4 first. I know that's what's called a difference of squares. So that's going to factor to x plus 2 and x minus 2. Over on bottom we have the same kind of difference of squares here. That's going to factor to x plus 1 times x minus 1. We have times x plus 1 I can't factor at all. And then down here we have this x squared plus 2x. Now both of these have an x in common, so I should be able to factor out an x. And on the inside have x plus 2. So if I distributed this x back out, I would get x squared plus 2x. So now I have a bunch of factors here. So anything common on top and on bottom, I can cancel out. Let's use a fun thing here. Let's see what this does. Alright, so I have an x plus 2 there and x plus 2 there. X plus 2 canceled out. I have an x plus 1 here and an x plus 1 here. Those cancel out. Now I don't see anything else that we have in common on top and bottom. So I'm going to rewrite my expression as x minus 2 over x minus 1 times x. I like it this form. It's a little simpler to handle. If you want, you can distribute out this x though. And the same thing is x minus 2 is equal to x squared minus x. So there's your answer, or there's your answer. Either one of them would work. All right, last problem. Take a look at this guy. So this is probably the hardest looking problem or most complicated looking problem you've ever seen. It's actually quite easy though, if we break it down step by step. So we have a fraction. So we have a fraction here divided by another fraction. So I'm going to rewrite this and just say it's this divided by y plus 3y, sorry, this should be a squared here, y squared plus 3y minus 10 divided by 2y. So we have a fraction divided by another fraction. So this is another way to rewrite it. Even better way to rewrite it, if we have a fraction divided by a fraction, we can change it to multiplication if we take the reciprocal. So if I flip the numerator and denominator here, I could change this to multiplication. So let's do that, and then it'll be similar to the last problem we looked at. So I'm going to flip this. I'm going to say times, I'm going to put my 2y on top, and I'm going to put my y squared plus 3y minus 10 on bottom. Alright, let me erase this so it's out of the way. So this is actually the same problem that we started off with. It's just in a little easier looking form to handle. Alright, let's do some factoring then. So on top I can factor this down to y minus 6 and y plus 1. On bottom I just have a y times y times y, right? That's all y cubed is. You can leave it as y cubed if you want to. On top I have a 2 times a y. And on bottom I can factor this down to, let's see, y plus 5 and y minus 2. Is that right? Plus 5 minus 2. That should work. And this a minus 6 plus 1. Alright, so what can I simplify here? On top and bottom. Y minus 6. There's no y minus 6's on bottom. Y plus 1. No y plus 1's on bottom either. Looks like the only thing I can cancel out here is one of these y's with one of these y's. So on top, I have, I'm going to write this 2 first. We have 2 times y minus 6 times y plus 1 all over y plus 5 times y minus 2. So we did all that work, all that factoring to just cancel out one y. What a drag, I know. So let's leave this problem like this. We can multiply everything out if we wanted to, but your answer is just fine like this. It's a little bit nicer and neater, I think. All right, that's it for today. 9 minutes, not too bad. You guys have a good day.